Okay, so permutations and combinations. This is an important chapter. A lot of questions are asked regularly in NDA on this particular chapter. So we'll start with the basics, with the counting. So we'll learn about the fundamental principle of counting. So we'll count mostly number of ways in this chapter. How many number of ways are there? Count mostly that. Okay. So let's now start with the discussing about events. So let's say how many, let's say there is one point and there is another point. How many ways are there to draw a straight line between these 2 points? If I have to draw a straight line between these 2 points, I guess there is only one way. Right? This is the only possible straight line that can be drawn in between these 2 points. Right? What if there are 3 points? How many straight lines can be drawn in between 3 points? One, and other one can be drawn from here to here. Yes, another one can be drawn from here to here. So there are three number of ways. There are three possible straight lines. If I increase one more point, then okay. So how many straight lines? So in starting we had 2 points. 2 points had one straight line. 3 points, three ways. Three straight lines were there. Now 4 points. We have 1, 2, 3. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, and no, yes, 6. 1, 2, 3. Yes, yes. There are 6 ways for 4 points. So basically, I'm counting the number of ways here. Now, this is one event. Okay, what was the event? Forming a straight line. This was the event. Okay. Now, events are of two types. I have just given you an example of events. Now we'll talk about events. Events are of two types. Dependent events. We're talking about plural events. Dependent events. Dependent event means that if there is, let's say there is a event and there is a B event. So the B event is dependent on A event and A event is dependent on B. It can be like say if only A happens, then only B happens, something like this. So mm, let's say you are at Rajasthan, my state, our state, okay, and you have to go to Maharashtra, and then from Maharashtra you have to catch a train. You can go, then you have to go, let's say Tamil Nadu. Okay, so from Rajasthan to going, let's say from Rajasthan to Maharashtra, there are n1 number of flights. From Maharashtra to Tamil Nadu, there are n2 number of flights. Now from going, and let's say there are no direct flights from between Rajasthan and Tamil Nadu. So so for reaching Tamil Nadu, the event A, that is from reaching, that is from uh, that is for reaching to Maharashtra from Rajasthan. There are n1 number of ways, and for reaching Tamil Nadu from Maharashtra, there are n2 number of ways. So now, now this number of ways are dependent. Only when you will reach Maharashtra, from Rajasthan, then only you will be able to reach to Tamil Nadu from Maharashtra. So the B event is dependent on A event here. So the total number of possible events, if I were to write total number of possible ways to go from Rajasthan to Tamil Nadu is N1 and N2. So in case of dependent events, if there are N1 ways for A event and N2 ways for the B event, then the number of events are going to get multiplied, and that's going to be the answer of total number of ways. Is that clear, everyone?
Yes, sir.
Yeah. And it's just not like that only, that B has to be dependent on A. It can be written otherwise also, and still the number of ways will get multiplied. Let's discuss about independent events now. So if we take another look on dependent events, we can also say like the A happened and B happened. So number of ways for A and B, and is for the dependency of A and B. In this case, independent events are there. Let's say from reaching from Rajasthan to Tamil Nadu, there are N1 ways through bus. There are N1 routes through bus. Okay, that's E event. Let's call it a E event. And there are N2 ways while going from the train. Let's say this particular event as B. So now these two are independent events. They are not dependent on each other. So now the total number of ways for going to Tamil Nadu from Rajasthan is N1 plus N2. And we may write here A event or B event is happening. They are not dependent on each other. So in this case, the total number of events will get added. Is this clear, everyone?
Yes, sir.
Yes, so it is so. Please note this particular thing that or and end is important here. Okay, let me summarize and write it in a separate slide also. So this is fundamental principle of counting. So in case of dependent events, if there was a event, or let's say a event had m number of ways and B event had n number of ways to get it done. Now the A and B event had m the product of m into n number of ways for A and B event to happen. Okay, so this is about dependent event. Now let's discuss about independent events. Let's assume the same. A and B are the events with m ways and n ways. Now this time A or B will have m plus n number of ways. Okay. This is the difference. Clear?
Yes, sir.
Let's take some example. Okay. So I have a interesting example with me. The question says, let me type the question. It's going to take time, but let me do it. Train is going from Cambridge to London, stops at 9 intermediate stations. 6 persons enter the train during the journey with 6 different train tickets. How many different ways, sets of tickets they have had? So now this is the question, interesting one. So a train is going from Cambridge, let's write C for the Cambridge, and is going to the London. Okay, so let's draw the track. That's a track. Now there are 9 stations available. So let's write S1 for station number 2, S2 for station number S1 for station number 1, S2 for station number 2, S3, S4, S5, S6, X7, S8, and S9. There are 9 stations in between. 6 persons enter the train during the journey with 6 different tickets. Okay, so now we are not clear that uh, these 6 persons where they have boarded the train from. We just had to find out that how many different sets of ticket they have had. Okay, so let's say for S1 station, how many stations are there? Tell me the number of stations that are there ahead of S1. Now, London is also a station, remember, and Cambridge is also a station. How many stations are there ahead of S1? It's simple. Uh, Ahead of S1, there is 1, 2, 3, 4,
8, sir.
5, 6, 7, 8, 9 stations
4,
available.
including London.
Yes?
Yes, sir.
Yeah. So for S1 station, there are 9 stations here. S2, there are 8. S3, there are 7. Similarly, for S9, there is the last station available, that is London. Okay. So hence it is clear that the total number of now we know if there are 9 stations available, then if you are going to buy a ticket from S1 station, then you can buy a ticket for S2, S3 or S4 or S5 or S6 or S7 or S8 or S9. So, or for London. So you can buy ticket for 9 different stations, right? So how many tickets can be bought from the S1 station? 9 only. Yes, is that clear?
Yes, sir.
Yeah. So there are 9 different tickets that can be bought from the S1 station. Similarly for S2, similarly for S3. Now on the 9th station, only one station is left, so only one station ticket is can be bought. Okay. If that is clear now, the total number of different tickets will be uh, 9 from the S1, 8 from S2, 7 from S3. Now we are going to add them. We are not going to multiply them. Why? Because they are independent events. They're not dependent on each other. You can buy any ticket from any station. But just that key you are going to, of course, if the train is going in this direction, so you can only buy the ticket from the next station, not for the previous station. That is for sure. So it's an independent event. It's not dependent on which ticket is bought from the previous station, right? So it's an independent event. So the total number of different tickets is 9 plus 8 plus 7 plus 1 till 1. So we know the formula of n, that is 1 plus 2 till n, and that is n into n plus 1 by 2. Now here we are finding the sum till 9. 9 into 9 plus 1, that is 10 by 2, that is 45. Is that clear, everyone? How we have applied this formula? This will come
Yes.
out as 45. This is the sum of natural numbers starting from 1. Okay. So is that clear till now?
Yes, sir.
So now in the question it is given that 6 persons enter the train during the train journey with 6 different tickets. So 6 persons will be having 6 tickets, and it is also given that they all are different tickets. Okay, how many different tickets can be possible is 45. Now these 6 tickets should be out of 45. So how many different sets of tickets they have had is that the selection of 6 tickets from this 45. So it's like slide change, please. Yes. It's like selecting it's like selecting 6 different tickets from 45 different tickets. Okay. So the formula for selecting some things from the total bulk is given by this, and we are going to talk about more about this particular combination later, but the answer for the question will be written like this. This is representing, like NCR represents selection of R elements from N elements. So that's like the total number of ways of selection of R elements from N elements. We are going to talk about more later. This is known as a combination. Okay, we'll talk about it more later on. But currently, you just have to understand it. That's how the final answer is going to return. The concept is here that the total number of different tickets will be 9 plus 8 plus 7. We are going to add them more. Is that clear, everyone?
Yes, sir.
Yes, sir.
Great. So So before moving ahead, let's discuss an important topic. Do you all remember what is the greatest integer function? Anyone? Can anyone tell me the answers, please? Yes.
Sir, is it the near number we used to say that one? Like,
No, it's not the near number. It's the
0.1 means
0 means it's 1, I think.
no,
1. Or
no. It's the like
It's 1.
part of the number that is there. Any number was able to express itself in its these two formats. Okay, and the integer had to be integer, and the fractional part can only be positive. So let's say if we have to write 0.1, 0 plus 0.1, we have to write 2.5, then 2 plus 0.5. If we have to write minus of 3.5, then this fractional part can never become 0, can never become negative. So this is plus 0.5 minus of 4. Clear? So now this is the greatest integer function of this, and this is the fractional part of this. Is that clear, everyone? And also there is one more way to find it, that if there is any number and it's there on the number line, let's say this is the number line, plus of infinity, 0, 0.1, 2.5, let's say, and there is 2, there is 1 here, not 0.1. It's 1 there, there's minus 1 here, there's minus 2 here, and there is minus of 3 here. Okay, so if we have to find out about 2.5, will come from the left hand side, and whichever after reaching to the specified number, we'll check the last integer that was there, that's 2. So its integer in its greatest integer is 2. Okay, if we have to find out for 0.1, which is here, so we'll come from the left hand side. Okay, after reaching, we'll check the most nearest integer to its left hand side, that is 0. Okay, now for 0. Minus of 0.1, will come from left hand side after reaching. After reaching here, we'll check the nearest integer to its left, which is minus of 1. For minus of 3.5, this should be minus 3.5 here. Will come from the left hand side after reaching. We'll check the nearest left hand side integer, that is minus 4. That's also another method. Clear, everyone? What is the greatest integer function? Basically, the integer that is there for positive numbers, the same integer will be written. For negative number, the integer minus 1 will be written. This is a better way to remember it, and that's an understanding. Clear, everyone?
yes, sir.
Okay, so now we are going to, so let's say if there is any number 256, so how to prime factorize it? We write 256 here, then the first prime number 1, 2, 8, 6, 4, 232, 216, 28, 24, 22, 21. So how many twos? 3, 3, 6, 2. 6 and 2, 2 raised to power 8. So basically 2 raised to power 8. That is the prime factorization of this particular number. Okay. Now what about 5 factorial? That is 120. And we'll find out its prime factorization like this. 122 raised to power 2 into 6. 120 by 2, 60, 30, 15. Now it will be get divided for the next prime number, that is 3. Now for the next prime number, that is okay this. So its prime factorization will look like 2 raised to power 3 into 3 raised to power 1 and 5 raised to power 1. So my point is, if we have to find out, let's say for 6 factorial, write 720 here and 2 raised to power 4 and 3 raised to power 2 into 5 raised to power 1. That will be its prime factorized. If we have to find out the exponent of prime p in n factorial, let's say for exponent of 2 in 6 factorial, then we can see here what is the exponent of 2 in 6 factorial. That's 4, right? Isn't it? That is 4, right?
Yes,
So
sir.
it is 4 here. Now let's say finding out the exponent of 3 in 6 factorial. That is 2 here. Finding out the exponent of prime 3 in 5 factorial, that is 1. That is 3. Finding out the exponent of 2 in 5 factorial, that is 3. But we cannot do the same for 10 factorial, let's say, because 10 factorial in itself, the number is very great. So the prime factorization will take a lot of time. So there is a method to find out the exponent of prime p in n factorial, and we are going to discuss the same. So the method says, so let me write, if you have to find the exponent of n factorial and exponent of prime p, then what we'll do, we'll take the greatest integer function of n after getting divided by p, and we'll keep on doing so, and we'll keep on raising the power of prime we'll keep on raising the power of prime till it has not become 0. Okay, so you will be able to understand it once we have done it only by ourselves. So we had taken an example of exponent of 2 in 6 factorial. Let's try to find out this. So this is for example purposes. So exponent of 2 in 6 factorial. N is 6 here, divided by 2 plus 6 divided by 2 square, 4 plus 6 divided by 2 cube, that is 8. Now we can stop. Okay. Why exactly? I'll tell you later. 2 raised to power 4 is 16. Okay, it will go on like this. 6 by 2 is 3. Now the greatest integer of 3 is 3 only, because it is itself an integer. Okay, great. Plus 6 by 4 is 3 by 2. 3 by 2 is 1.5. Its greatest integer function is, it's a positive number, so its integer will only be the greatest integer function. Cool. This is what 3 by 4. 3 by 4 is 0.75. Its greatest integer function is 0. Plus 6 by 16 is 3 by 8. 3 by 8 is 0.75. 3. Yeah, something. So 0.87 jar 56. 67. 0.37. Its greatest integer function is 0. So basically it will keep on becoming 0 only. Okay. So now here we can observe that 3 plus 1 is 4. And that should be the answer. Let's check. Yes, we are able to find out exponent of 2 in 6 factorial using this method. Now, when should we stop applying this particular method? When the numerator has become less than the denominator. Basically, then, because we know then the greatest integer function will be becoming 0. Is that clear, everyone? Is the application of given formula clear?
Yes, sir.
The moment our numerator becomes less than the denominator, we will stop calculating it. Let's take some more example. Let's try to find out, and we'll only be doing with prime numbers. Okay. So let's try to find out the exponent of 4 in 6 factorial. Now, will we be able to do so? Anyone? Can we find out the exponent of 4 in 6 factorial? Is 4 a prime number?
No, sir.
So will we be able to find out the exponent of 4 in 6 factorial?
No, sir.
Oh yes, we will not be able to find out using the same formula, but using our brain, we'll be able to find out. How so? So first, we'll break down this. So it is 4 is 2 raised to power 2. So what if we find out the exponent of 2, then divide it by its power, right? Because if there is, let's say, if 16 is 2 raised to power 4, and then it can be similarly written as 2 raised to power 2 raised to power 2. So actually 4 raised to power 2. So the power got divided by 2. Okay, similarly, we'll be able to find out the exponent of 2 in 6 factorial first. So basically 6 by 2 plus 6 by 4 plus 6 by 4 to the 8. Now we'll stop calculating. 6 by 2 is 3. This is 3 by 2, 1.5, basically 1. This will become 0. So 3 plus 1 is 4. So basically 6 factorial has a factor 2 raised to power 4. If it has a factor 2 raised to power 4, we can modify it 2 raised to power 2 raised to power 2. So we can write it as 4 raised to power 2. So the exponent of 4 is here 2. That is our answer. Clear, everyone? So please do not be restricted with the formulas that is given to you, and use your brain that how we can further utilize our knowledge. Clear?
Yes, sir.
Yes. So let's say there's 10 factorial. Okay. Instead of 10 factorial, let's take 9 factorial. My question is, will 9 factorial, is 9 factorial divisible by 10? Anyone? Is 9 factorial divisible by 10? It's completely okay to give incorrect answer, but just try. Think.
Yes, sir.
Yes. Why?
No, I just multiplied the answer and said it, sir.
You just.
What is the 9 factorial? And then I said it is divisible by 10.
Okay. So if we expand 9 factorial, that is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So basically, 10 is what? 10 can be written as 5 into 2. So wherever there will be factors 5 and 2, then that particular number is definitely divisible by 10. Okay. So here there is a 5. Yes. There is a 2. Yes. And there are two twos more. Like this 4 can be written as 2 2. Right. So this is definitely divisible by 10. Now my point is to find out whether some particular number is divisible by 10 or not, simply write its prime factorization. And look for pairs of 5 and 2 because 10 is not a prime number, 5 and 2 are. So definitely look how many maximum number of pairs you can find out of 5 and 2. Let me give an example of let's say 2 raised to power 1, 3 raised to power 2, 5 raised to power 3. How many pairs of 5 and 2 are there? Let's say this is some number A. How many pairs you can make? So if I rewrite it, 2 raised to power 1, 3 raised to power 2, 5 raised to power 1 into 5 raised to power 2. One pair of 2 and 5 only, right? If I rewrite 2 raised to power 3, 3 raised to power 2, 5 raised to power 1, 5 raised to power 2. How many pairs of 2 and 5 can be made? 2 raised to power 2 into 2 raised to 2 into 3 raised to power 2 into 5 raised to power 2 into 5. So, two pairs of 2 and 5 can be made. Getting me? So, like basically the minimum number of uh, exponent of 5 or 2 in most of the cases. But when we talk about factorials, when we talk about n factorials, then what is happening? There are always more number of exponents with 2, but less number of exponents with 5, of course, right? Because in every factorial that is greater than 2, it will be definitely having 2 for sure. And even more values of 2 will be there after like after shorter distance, there's like this is 2 raised to power 3, this is 2 raised to power 2. So definitely for any n factorial, there are abundant. Abundant means enough, right? Is I'm correct? Am I correct? Abundant means enough, right? Please help me with the vocab, yaar. Existing in very large quantities, more than enough. Yes. If there is a discussion of n factorial, so there will be abundant twos. What we have to be concerned about the exponent of 5. So my point is, my conclusion is, okay. So my conclusion is, whenever you have to find out the number, whenever you have to find out the number of zeros, number of zeros is equivalent to 10 raised to power n being divisible. Okay, if let's say if there is a number 10, so it's divisible by 10, of course. If there is a number having two zeros, so it's divisible by 10 raised to power 2, right? So similarly, if we are discussing about 10 being divisible or 100 being divisible, so we are discussing about the number of zeros that are there in any number, right? So if we have to find out the number of zeros in n factorial, then we have to look for the exponent of 5 in n factorial. Is that clear, everyone?
Yes, sir.
Yes, that's the conclusion. So if there is any question like this, that find, and now number of zero means that how many zeros are there at the end of this number. Let's say 2200 have two zeros. 2304000 also have two zeros at the end. Okay, 440000 have four number of zeros. Clear, everyone?
Yes, sir.
If we have to find out number of zeros at end of, let's say, 100 factorial. So we'll find out the exponent of 5 in 100 factorial by using the same method. 100 divided by 5 plus 100 divided by 5 square, that is 25, plus 100 divided by 5 cube, that is 125. And that's when, and that is when the numerator is less than the denominator. So 100 by 5 is 20, that is 4, that is 0. So this is 24. So there are 24 number of zeros at the end of 100 factorial. Is that clear, everyone?
Yes.
Yes. So I am starting this topic a little late, but I'm sure that you are aware about factorials. We'll be only able to find out the factorial of integers and I should say whole numbers. Whole numbers are 0, 1, 2, 3, and n. It's going to positive infinity. Okay, so factorial of 0 factorial is 1. Let me say it. 0 factorial is 1. 1 factorial is 1. Basically, if we have to find out the n factorial, any numbers factorial, so we'll multiply n with n minus 1 into n minus 2. And we have to keep subtracting and multiplying till n becomes n minus of n of 1 till then. Okay, so basically for 1 factorial it is 1. For let's say 10 factorial it is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Now I have to stop before 0. So similarly 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2, that is 6, 4 factorial is 6 into 4, that's 24, 5 factorial is 24 into 5, 120. Now, why I'm writing so? 3 factorial can be written as 3 into 2 factorial, and 4 factorial can be written as 4 into 3 factorial, and 5 factorial can be written as 5 into 4 into 3 factorial, or 5 into 4 factorial. You got the idea, right? Here also, n factorial can be written as n into n minus 1 factorial, or n into n minus 1 into n minus 2 factorial. Clear? 6 factorial can be written as 720, 7 factorial is 5040, and that's enough for you to remember. You have to learn till 7 factorial and also learn the value of 9 factorial. And this is that amazing number which is divisible by all the numbers, like all digits from 0 to 10. Clear, everyone?
Yes, sir.
3,62,880. It is divisible by everything. You can challenge your friends. Okay, so that's about factorials. And let's discuss more about factorials. Why exactly 0 factorial is 1? That must be shocking for you. Because what we have just discussed, that for any n factorial, we'll keep on multiplying n with, after subtracting it, before it becomes 0. Okay. So similarly for 0 factorial, when we start, then it becomes 0 only. So it's 1. And also there is one more logic. If we write 5 factorial, that is 120. If we write 4 factorial, that is 24. If we write 3 factorial, that is 6. So basically what we are doing, 5 factorial is 5 into 4 factorial. So for finding out the value of 4 factorial, divide 5 factorial by 5, that is 4. So from here we can derive a formula that n factorial divided by n is n minus 1 factorial. So similarly, when we will find out the 0 factorial, so for 0 factorial, n should be 1. So for 0 factorial on the right hand side, that should be 1 factorial divided by 1. So 1 factorial by 1 becomes 1 only. So 0 factorial hence becomes 1. Otherwise also, dividing 120 by 4 becomes what, 24. 24, sorry, 24 by 5, now 24 by 4. Now for finding out 2 factorial, divide 6 by 3. That is 6 by 3 is what, 2. For 1 factorial, we'll divide 2 by 2, that is 1. For 0 factorial, we will divide 1 by 1, that is 1. That's why 0 factorial is 1. Clear?
Yes.
Any doubts? Anyone? No doubts. Great, great, great. So, shall we start another topic? Let's just start and we'll discuss about it more in today's class, in tomorrow's class. So, the next topic is permutations. Now, if you will Google the meaning of permutations, you will get this answer. Listen.
Permutation. Permutation.
अरे भाई बोलो भी. So it's written is any of the different ways in which a set of things can be ordered. Okay, can be ordered. If you have, let's say, if you have English book, book number 1. If you have Hindi book, if you have social science book, you have 3 books. So, and you have a stack. You have a Almira, let's say. It is Almira. And you can place the first book like this, the second book over it, third book over it. But which book should be there? And let's say this is one way, this is another way. This is one way to say, this is one way where you can arrange 3 books. And there is another way where you can keep the second book, then the third book, then the first book, and different arrangement. So the total number of arrangements are find out by permutation. So that's simple definition of a permutation. Now, if we increase the slot size, then it becomes a typical. If instead of, like, there were 3 places and there were 3 elements that needed to be placed or arranged here. But what if there are like more number of spaces? Instead of 3, there are let's say 1, 2, 3, 4 spaces are there. And now you can now you have 3 books. Okay, so the space for the book is 4, and the elements that are needed to be arranged are 3. So there are 2 variables here, right? 2 variables here. Okay, we'll discuss about it more in tomorrow's class. Till now, ruminate over how many different ways can be there for different things, and where the order matter, where there is no order or arrangement matter. Let's say in set 1, 2, 3 and 3, 2, 1, 3, 1, 2. They are 2 equal sets. Order doesn't matter here. For matrix, there are no equals. Order matters here. Okay. So there are different things, and please think over it, and also revise these notes that we have studied today. The fundamental principle of counting, dependent and independent events. That is the first lecture of permutations and combinations. Any doubts?
No, sir.
It's a very interesting chapter. Give this time. No doubts, anyone?
No, sir.
No, sir.
Okay. Then thank you